Okay, we have one final thing on mixed models. I very briefly mentioned mixed models before. Let's imagine you have this kind of data sets that we were discussing before. You have bikes versus faces. And let's say you have 13 subjects, 11 items, 4 repetitions in total, 1,100 tries. Wait, items? What the heck is an item, right? Oh, one more new thing to learn. But items are really important concept. They come, I think, mostly from psycholinguistics. And if you do an experiment, you're typically using different faces, different words, different sounds, etc. So, for instance, if you have a face stimuli, each face looks slightly different. So, if I show you a face, you will always get an ERP, a single face ERP that looks a little bit different. Yeah, like Romy says, words are people too. So we can play around with this. And what I have here is I have this typical two-stage t-test, so between faces and bikes. And I also have a linear mixed model. And I want to just show you, okay, if I add a fixed effect, right, then the p-values go down. Okay, that's not surprising. If I don't have a fixed effect, so the null hypothesis is true, what happens now if I add more variability between these individual phases, right? What's happening is that the t-test at some point, it gets significant, but the LMM correctly says, nope, there's no fixed effect. It's still at 0, right? So we have an issue here, apparently, that if we have variability in the items, that we have to account for that. And the reason is that if I show you, there's a difference between showing 100 times the same face or 100 times 100 different faces, right? Because the same face will elicit, on average, a more similar ERP for each of the things than if I vary the face that I'm actually showing. Okay, so item effects inflate type 1 errors. This is what you should take away from this. And I think most experiments have item effects to some extent, or other kind of effects that you could model with linear mixed models. Linear mixed models have other benefits as well. You can do missing data or unbalanced designs easily. You can use multiple continuous variables in the interaction, etc., with repeated measures. So you would in a linear mixed model analyze all data at the same time. And of course, well, you can make your analysis more fancy, and then that's all. Right now, with all the deep learning rage, that's a good thing to have complex models, right? Okay, let's simulate using UnfoldSim. Thank you, Judith. 10 subjects here. We reshape the data a little bit, blah, blah, blah. This is a little bit boring. But we have EEG data here now, 1 channel, 45 time points, 1,000 trials. 1,000 trials, not all the trials belong to the same subject. You can see here we have a column for subject now, and at some point it will flip over to the next one. Okay, after 100 trials, it will flip over to the subject number 2, right? Okay, we now have to define a linear mixed model formula. So then this one, you know already, this part. This part is a little bit new, and I cannot possibly go into the explanation of how exactly to interpret this, but be assured there is some modeling of the item variability and some modeling of the subject variability, what we typically want. Now, the unfold model command actually looks exactly the same that you had before. Like unfold knows that because there is this kind of grouping in there, it should apply per time point linear mixed models and not a linear model anymore. So that's nice. That's convenient. We can also use pretty much the same plot ERP command. Now we just have to tell the plotting command, okay, split up by group, because now we have the fixed effect. So this is what's true, what's really a literal ERP change. And this would be variabilities here, item variability and subject variability. And as you can see here, there is a difference between conditions, blah, blah, blah. I'm not going into the details, but you can see that over time, the variability of the item and of the subject effect varies, right? Unfold mixed model also allows you to do p-value calculations here, for instance, likelihood ratio tests. So I'm going very quickly. If you never heard of likelihood ratio tests for linear mixed models, then this is what you need to take from it. You can do p-values with it. If you have heard of it, then you find that might be convenient that you have functions to do that, and you can do some kind of p-value plot over time. So this is p-value on log scale. And now somebody might argue, oh, okay, but wait, you're doing so many statistical tests. How do you do cluster permutation testing for mixed models? How is that even possible? And thank you for asking this question. because it's really difficult, but we are actively working on this. So we have two different packages, especially the mixed models permutation package, where we developed a new permutation test for mixed models, so we can do cluster permutation testing, and it's implemented and it works, and you get out some kind of cluster, something like this here, and you even because we're using this fancy cluster depth algorithm, which I think everybody should check out. It's so cool, much cooler than TFCE and the stuff. I think it's a new cool kit. We even get interpretable p-values per time point, even though this is a cluster test. How cool is that? I can even really say this is the p-value of that point, right? Very convenient. Anyway, LMMs, I think, can be super important in many situations, especially in psycholinguistics, but I think actually everywhere, but people just don't realize it. And you can fit this mass-univariate LMMs in Unfold. And now can I fix this? Okay, warning, more research is needed. Contact me if you're interested to work on this, right? Yeah, thanks. Any questions? We're happy to take them. Okay, this doesn't seem to be the case, but if you get questions later, please. We have extensive documentation. We are really keen to collaborate with people. We have a lot of collaborations already helping out people. If it's just typically it's just an email or an issue or a discussion, GitHub discussion, just reach out. We are very happy to help and spread our knowledge that we already gained.